All right, today we are cracking open one of the most important and maybe most overlooked pieces of tech that powers our entire world, the Humble Transformer.
You've definitely seen these things around. You know, those humming gray metal boxes that sit on top of utility poles or on concrete pads in your neighborhood. They're so common, we just kind of tune them out. But honestly, without them, our electrical grid would just stop. So, have you ever actually stopped and wondered, what's really going on inside that box? Well, today we're going to pop the lid and find out.
Okay, so before we get into the nuts and bolts, let's start with the big picture. What is a transformer's fundamental job? Why is it so absolutely critical for the grid?
So, at its very core, a transformer is a device that moves electrical energy from one place to another. It uses an invisible magnetic field to do it, and this is key, it does it all without messing with the frequency of the power. It's this amazing ability to change voltage up or down that makes our power grid even possible.
So how does it pull off this electrical magic trick? Well, the science behind it is actually surprisingly simple and pretty darn elegant. It all boils down to something called electromagnetic induction. See, when an alternating current, that's the type of electricity we use in our homes, flows through a coil of wire, it creates a constantly changing magnetic field all around it. Now here's the cool part. If you put a second coil of wire near that first one, inside its magnetic field, that field actually creates a brand new current in the second coil. They don't even have to touch. Power is literally jumping through an invisible field. And this is where the real genius comes in. By simply changing how many loops of wire are in each coil, you can change the voltage. A step-up transformer has more turns in its second coil, which boosts the voltage way up for efficient long-distance travel. Then, a step-down transformer, like the one in your neighborhood, has fewer turns, bringing that voltage way down to a safe level for all your stuff at home.
All right, now that we've got the theory down, let's do it. Let's open the box and meet the main players that make all this happen. Right at the very heart of the whole thing is the magnetic core. You can think of this as the superhighway for all that magnetic energy we were just talking about. Its entire job is to guide that magnetic field, that flux, from the first coil over to the second one as efficiently as possible. It's made of a special kind of steel that's designed to let the magnetic field pass through really easily, which is exactly what you want for minimizing energy loss. And wrapped around that core, you'll find the parts that do all the heavy lifting, the windings. These are those copper coils we've been talking about. Every transformer has two sets. You've got the primary winding, which takes power in, and the secondary winding, which sends the power back out at the new voltage. They're almost always made of copper, but here's the catch. Even copper has a little bit of resistance. So as all that electricity flows through, some of that energy gets lost as heat. We call this copper loss, and managing that heat is a huge, huge part of designing a good transformer. So all these critical internal parts need a safe place to live, and that's the main tank. This is the big, tough metal box that you actually see from the outside. The tank is this super durable container that holds the core, the windings, and also, very importantly, the transformer's oil. And you see those things that kind of look like big ceramic posts on top? Those are called bushings. They are absolute heroes. They're insulators that let the dangerous high-voltage cables connect to the windings inside without electrifying the entire metal tank. Super important. Okay, so we know how it works, but how does it keep from just overheating and failing spectacularly? Well, that's where all the support systems come in. Remember all that heat we talked about from copper loss? To get rid of it, the transformer has its own cooling system. And these fins you see on the side, they work just like the radiator on a car. Inside that tank, there's a special oil that actually does two jobs at once. It insulates all the components, and it absorbs heat. As that oil gets hot, it naturally circulates out into these fins, and the huge surface area lets all that heat escape into the air. Then, the cooled oil just cycles right back in. Pretty clever. Now, as that oil heats up and cools down, it expands and contracts. This means the transformer actually needs a way to breathe air in and out, but without letting in moisture, which would be a disaster. And that is the job of this little guy, the breather. Here's how this works. When the transformer gets hot, the oil expands and pushes air out. Simple enough. When it cools down, the oil contracts and it sucks air back in. But that air outside has moisture in it, and water is the enemy of insulating oil. So the air gets pulled through some silica gel inside the breather, which acts like a filter, grabbing all that moisture before the clean, dry air gets inside. But what happens if something goes really, really wrong on the inside? For that, Transformers have a guardian angel. It's called the Buchholz relay. This thing is an absolute lifesaver. It's a safety switch that works with gas. So if there's a massive internal fault, like a big electrical spark, the intense heat literally boils the oil around it, creating a sudden burst of gas. That gas rushes upwards, and the Buchholz relay detects that flow and, bam, it instantly trips a circuit breaker, shutting the whole transformer down before it can destroy itself. So when you put all these different pieces together, the elegant physics, the super robust construction, and all these clever safety systems, you end up with something that is truly remarkable.
And the end result of all of this is just wow. A big, practical transformer can have a full load efficiency of over 99%. Think about that. It's one of the most efficient machines that we have ever created. Almost zero energy is wasted moving incredible amounts of power. And that is why it's the absolute backbone of our modern world. From the gigantic units you see at power plants to that small can on your neighborhood corner, these unsung heroes are absolutely everywhere, just quietly, almost perfectly, doing their job day in and day out. It leaves you with a final thought, right? As our world's appetite for power just keeps growing, what will the next innovations be for this nearly perfect and totally essential machine?